This video discusses system parameters for Dynisco's online rheometers. System parameters are fixed variables and machine hardware settings that are used in the calculations for melt flow rate, viscosity, and intrinsic viscosity. These are set in the equation constant screens and fall into two categories. One being physical hardware settings, which define the hardware devices that are part of your system, and the other being constants for equation calculations. The first thing that appears under equation constants is capillary geometry. These settings are used in melt flow rate and viscosity calculations. As you can see here, one sets the capillary diameter and the capillary length to diameter ratio. These settings can be simply entered or selected from a list that has been programmed into the system. When your new system ships, the capillaries that are ordered at that time will be set up in your system and shown on this screen. As you can see, you can select a capillary by part number or capillary diameter and length. On the selection pull-down is the entire list of capillaries possible for the system and is simply set on the main screen shown here. If capillaries are predefined, they can be picked from the selection based here by selecting the 1 through 10 buttons as they were entered in the predefined list. As one selects a number, the capillary geometry will appear for clarification. Also on this screen is melt flow rate correlation factor. Some materials need a correlation factor due to flow characteristics of the material through the rheometer versus a straight path melt index or tester. This can be initially established with each material by comparing rheometer results against lab measurements. The correlation factor is simply a scalar to line up the rheometer melt flow measurement with your lab measurement going forward. Identifier is an alphanumeric designator you may want to identify your capillary. It could also simply be a grade designator for a specific capillary. The next screen for calculation constants contains flow rate, activation energy, and flow density. Flow density, or specifically melt flow density, is very important for accurate melt flow rate measurements. If you don't know melt density, you can set a general value for your type of material, and then any error could be accounted for using the correlation factor on the previous screen. If you have a melt indexer, a method A/B test could be run on the material to determine melt density. Flow rate is related to pressure correction between process pressure and rheometer pressure. For most materials, those corrections do not need to be made. Please contact Dynisco for assistance to determine if flow rate entry is needed. Activation energy is used if the process and rheometer are run at one temperature, but the material is tested in your lab at another temperature. Usually, this involves cases where process temperatures are higher than the defined ASTM or ISO lab test temperatures for a specific material. To determine these values, one will conduct a series of tests on a melt indexer at different temperatures, and from those results, activation energy can be determined. Otherwise, leaving flow rate and activation energy at the default value shown ensures they are not part of the melt flow index calculations. If you would like assistance for determining activation energy from a series of melt index tests, please contact Dynisco. Going to the next screen of equation constants, pump volume is a fixed number based upon the pump installed in the system. Before system ordering, please work with Dynisco personnel to determine the best pump volume for your materials. Reference temperature is related to activation energy on the previous screen and is the laboratory temperature that the material is normally tested. Reference pressure, in conjunction with flow rate on the previous screen, is used for pressure corrections between the pressure of the process and the pressure of the rheometer. For most materials, these corrections do not need to be made. Please contact Dynisco if you need assistance with reference, pressure, and flow rate. On the next calculation constant screens are viscosity coefficients and corrections. Intrinsic viscosity coefficient and intrinsic viscosity exponent are constants used for intrinsic viscosity calculations. The default values are for PET material being tested at typical industry test conditions. For nylons and other materials, intrinsic viscosity measurements using the default constants may not be correct. After the rheometer is installed, compare rheometer results to your lab results, and those constants can be changed to baseline any differences. Also, IV correlation factor can be used to baseline the results as well. Melt viscosity correlation factor correlates viscosity measured in the lab versus measured with the online rheometer. Correlation may be needed if your lab measures viscosity in a manner other than a capillary rheometer, such as rotational or liquid varieties. Dynamic viscosity units can be set to Pascal seconds or centipoise. The viscosity correction screen is used for Bagley or Rabinowitz corrections for capillary material flow and capillary entrance geometry. These are shear stress corrections and shear rate corrections. For more on this topic, please refer to video Bagley and Rabinowitz corrections. Once set, the calculation constants variable will be used in the final material calculation as shown on your main screen, along with outputs for network connection, data logging, or analog usage. Dynisco online rheometers are recognized and used around the world for testing the physical, mechanical, and thermal properties of polymers. Experience the benefits of online rheology measurements to maximize extrusion efficiency, decrease your scrap rate, and increase your use of regrind and wide-spec materials with confidence knowing that the finished product is to specification. To learn more, visit dynisco.com/online rheometers.